Alright, today we're going to talk about 7-6, last section of this unit. Our objectives are to apply similarity properties in the coordinate plane and use coordinate proof to prove figures similar. Okay, given that triangle TUO, which is the smaller triangle, is similar to RSO, the larger one, find the coordinates of U, of point U, and the scale factor. Okay, so we need to set up a proportion. So on TUO, the smaller triangle, I have the measurement of TO, and it corresponds with, on the larger one, TO, RO. So TO is 9, RO is 12. And then on the smaller triangle, I'm trying to find point U, so I have OU over the larger triangle, OS. So this will be X. For the unknown in OS is 16. So there's our proportion. 9 over 12 equals X over 16. Do your cross product. Solve for X. And you should get that X equals 12. Now, we need to identify the coordinates for point U. Okay, so if it's 12 units, point U is 0, 12. So there's one of our answers. And then we need a scale factor. So let's go from point U to point S. Point S is 0, 16. So, how do we get from 12 to 16? And there's your scale factor. Okay, same thing. MON, similar to triangle POQ. We have coordinates of P and M and Q. Okay, so we have OM. OM corresponds with PO. OM is 10, because this here is negative 10. And PO is 15. Okay, and then on the smaller triangle, ON is which we don't have, so there's our variable, over OQ, which is 30. So here's our proportion. Do your cross product. Solve for X. Identify point N. So point N is going to be 0, negative 20, because it's right here. One of my answers. And then we need a scale factor, so let's compare it to point Q, which is 0, negative 30. So negative 20 times what gives me negative 30? And there's your scale factor. Okay, given triangle EFG. EFG. And triangle HJE. HJE. Okay, prove that these triangles are similar. Okay, so here are options. Angle, angle, side, angle, side, or side, side, side. And I can immediately look at this and see right here that angle E is congruent to angle E because of your reflexive property. Okay, then it looks like I'm going to have to use distance formula. Okay, so we need to find the distance of EH, EJ, EH, EJ, and EF. All right, so EH is going to be -4 minus -2 squared plus 2 minus -6 squared. And when I simplify all that out, I get 2 times the square root of 17. And then EJ, I'm going to take 6 minus -2 squared plus 2 minus a -6 squared. And when I simplify that out, I get 8 square root of 2. And EF, so I have -3 minus -2 squared plus -2 minus -6 squared. When I simplify it out, I get the square root of 17. Okay, so let's see, I have this measurement, I have EJ, so I have this measurement, I have EF, I have this measurement, and I'm missing one. Let's see, which one am I missing? I'm missing EG. So we need to do EG. All right, EG. So I take 2 minus -2 squared plus -2 minus -6 squared. And when I simplify that out, I get 4 square root of 2. Okay, now I can set up my ratios. So I have EH and EF. EH, EF, okay. Let me erase this. Okay, we said EH was 2 square root of 17, and we said EF was square root of 17, so that simplifies to 2. And then we need to set up EJ. EJ over EG. Okay, we said EJ was 8 square root of 2, and EG was 4 square root of 2. When you simplify that out, you get 2. So, what we have here then is EH over EF equal to EJ over EG. There's our two corresponding sides. Here's the including angle. So we can write our similarity statement that triangle EHJ is similar to triangle EFG because of side, angle, side similarity. All right, to save on time, this is going to be a candy question. prove on number 4, or explain on number 4, how you have these two triangles similar. And I'm going to move on because number 5 is different. Alright, graph the image of triangle ABC after dilation with the scale factor 2/3. Verify that the triangles are similar. Okay, I'm not going to graph, but what I'm going to do is list the coordinates for that image. So for A, if we take A and use a scale factor of 2/3, 3 times 2/3 is 2. For B prime, so we'll have 3 times 2/3, which is going to be 2. 6 times 2/3, which is 4. And then for C prime, we're going to get, where's C? 6 times 2/3, which is 4. 0 times 2/3, which is 0. So there's our image. How can we prove that they are similar? So we need to think side, 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 angle, angle. And we don't have any angle measurements, so we've got to go to side, side, side. All right, so distance here. So you need to find the distance of AB. And then we need to find the distance of A prime, B prime. All right, so AB would be 0 minus 3 squared plus 3 minus 6 squared. And when we simplify that, we get 3 times square root of 2. For B prime, or A prime and B prime, we get 0 minus 2 squared plus 2 minus 4 squared. And when we simplify that, we're going to get 2 square root of 2. Okay, then we need to do AC. A prime, C prime. All right, to save on time, I'm going to go ahead and get the answers here. So this is 3 square root of 5. And this one's going to be 2 square root of 5. And then our last one is going to be BC and B prime, C prime. So when you find the distance of BC, you get 3 square root of 5. And for the image, you get 2 square root of 5. So now we've got the distance of all of our sides. We need to set up our ratios. So here's one of my ratios right here. Pre-image, when I cancel that out, I get 3/2. Here's another one of my ratios. When I cancel that out, I get 3/2. And on my last one, here's my other ratio. Cancel it out, I get 3/2. Therefore, we can verify that they are similar because of side, side, side. That's it, guys.